now we'll discuss the chemical reactivity of these metals, these compounds. Chemical reactivity of group 13 elements. As we discuss the trend in electronegativity, moving down the group, electronegativity goes on decreasing. So, boron is electronegative, then having a high ionization potential, and if I consider a charge, it has a +3 charge, so high charge. Due to this, boron has a tendency to form covalent compounds. So, boron forms covalent compounds. So, BCl3, BF3 and so on are actually covalent compounds. While the other elements, aluminium, indium, gallium, okay, thallium we are not considering, is a radioactive. So, these elements actually form ionic compounds, rather form ions in aqueous solution. So, what is the reason behind it? Here the heat of hydration is greater than that of the ionization enthalpy, and therefore there is a formation of ions. In dry conditions or in a dry state, AlCl3, then GaCl3 or InCl3 are covalent in nature. Okay, this is one case. The second case is, now we know that indium and gallium or rather thallium, indium are actually having a two oxidation state, +1 and +3. So, thallium or rather indium and thallium in lower oxidation state forms ionic compound, while in +3 oxidation state forms covalent compounds. And it is because of Poisson's rule. Higher the oxidation state, smaller will be the charge, more polarization of electron causing. Now, all these elements, when they form a compound, has incomplete octet. For example, if I consider BCl3 or AlCl3 or GaCl3, 6 electrons in the valence shells, 6 electrons in the valence shell of the central atom. Therefore, these elements act as Lewis acid. So, BF3 when react with ammonia, suppose. So, ammonia is an electron donor. So, electrons are donated to boron. So, now we have a complex like this way. So, boron BF3 is what? Lewis acid. Okay. So, now we will discuss something about boron halide or the halides now. So, first of all we will talk about BX3, that is boron halide. Boron halides are a discrete molecules. So there is a formation of BF3, then BCl3, BBr3 and Bi3 also. The most stable one obviously BF3. Now here in this case, in all cases boron is sp2 hybridized. sp2 hybridized. So it has a trigonal planar structure. They have trigonal planar structure. And all have vacant p orbital, so they can accept electron pair. And hence all are Lewis acid. All are covalent compounds again. In case of AlCl3, in anhydrous case it is a covalent, but in aqueous case there is a formation of Al3 plus ion which get hydrated very easily because of the high charge and small size. AlCl3 can form a dimer like this way. So dimer, and it is because of vacant p orbital present in aluminium also. So why there is no formation of dimer in case of BCl3, BBr3, Bi3? Because in case of BF3, there may be a back donation. And hence there may be formation of what? P-pi interaction. So that lone pair is donated to the vacant p orbital. Since the size of the boron is very small and even the size of the fluorine is also very small, this back donation is possible. Therefore, BF3 or BCl3 are weaker acid than that of the AlCl3 or AlF3. Okay, it is expected that they should have a higher, stronger acidic because of the fluorine is pulling electron, but because of the back donation of lone pair of electrons to the vacant p orbital of boron, this is not the case over here. Okay. When we are talking about compounds like thallium, this or this, their existence are considered to be questionable, because in this case the oxidation state of Tl and ion is 3+, which is actually unstable as compared to that of this one, where the oxidation state is what? +1, because of the inert pair effect. So this is all about the halides. Then we will see few more periodic properties and then we will go for the compounds of boron and the properties of boron. Thank you.